Okay, objective 13 asks you to form composite functions. It's actually very easy to do this. We've done a lot of the preliminaries. If you got a function f of x and a function g of x, you can form f of g of x or g of f of x. Okay? So if f of x equals 2 to the x, well, we don't know what g of x is yet, but we know that we can do f of g of x because we've done this. We know that f of g of x is 2 raised to the g of x. In other words, x has been replaced by g of x, so we replace x by g of x. Something I hope everybody is very much used to by now. Okay, f of x equals 1 over x squared. What's f of g of x? You might want to think about it, pause the video for a minute, make sure you understand, but it's 1 over the quantity g of x squared. If f of x is log base 2 of x, then f of g of x is log base 2 of g of x. That much is easy, and the rest is also easy. So let's say here, let's say g of x is the squared function, basic squared function. Then f of g of x is going to be, well, it's 2 to the g of x, but of course that's just 2 to the x squared since g of x is x squared. So it's done very easily. Okay, for this one, let's let g of x equal, what the heck, x cubed. Haven't used that one a whole lot, other than the graph being anisymmetric and the numbers being a little bigger or smaller. It's a lot like x squared. Okay, if g of x equals x cubed, then f of g of x is 1 over g of x squared, as we've seen, and that's equal to what? 1 over x cubed squared, which is of course 1 over x to the 6th. These are new functions obtained by combining our basic functions. Okay? Now, let's take the log function. If g of x equals, let's say, the reciprocal function, 1 over x, then f of g of x equals log base 2 of g of x, which is log base 2 of 1 over x. Okay, now we've done f of g of x for each pair of functions. I'm just going to write down what g of f of x is. Might wave my hands and explain it a little bit, but okay, so for this one, g of f of x equals what? Well, g of x is x squared, so g of f of x is f of x squared, and f of x is 2 to the x. And that gets squared, and you should know by the laws of exponent that that's just 2 raised to the 2x. Okay, for f of x and g of x in the second line, g of x is x cubed. So g of f of x is f of x cubed, which would equal what? Well, f of x is 1 over x squared. So f of x cubed is 1 over x squared cubed, which is 1 over x to the 6th. And notice something. Here, g of f of x is 1 over x to the 6th. F of g of x is 1 over x to the 6th. They're the same. Does that always happen? Well, certainly not, because up here, g of f of x was 2 to the 2x, whereas f of g of x was 2 raised to the x squared. 2x is not the same thing as x squared. Completely different behavior. Okay? Then, in the third line, what's g of f of x? Well, let's see. What's g of x? It's 1 over x. So g of f of x is 1 over f of x. And f of x is log base 2 of x. So that's 1 over log base 2 of x. So this illustrates how you can form f of g of x and g of f of x if you're given the functions f of x and g of x. And right now we're just going to deal with these for just composites of your basic functions, and versus the basic functions is this one. We'll notice that again, the g of f of x is not equal to the f of g of x in this third case. I could comment that a lot of your basic functions are power functions, and if you do two power functions, f of x and g of x, different power functions, they're going to come out the same. For most of the other functions, it's not going to be so. Now later, we'll talk about domains and ranges of these functions. I'll just mention a little bit. For example, the log base 2 of x, remember the graph of that, doesn't include any negative numbers. So we can't have any negative numbers in this composite, so we have to restrict the domain. We have to state the domain cannot include, can include only positive numbers. It can't include 0 or a negative number. Whereas log base 2 of g of x, which is log base 2 of 1 over x, well, x can't be 0, because that would make this thing blow up. But any other value of x, any other positive value of x gives you a positive number that you can do log base 2 of. So we want to talk about that, but that's not going to be on the major quiz. We're going to talk about that very soon. So I thought maybe I'd toss that in right now, so it's worth taking note of. Okay. Very good. That's really all you need for Objective 13. All we're doing is forming composites of these functions. Figuring out domains and ranges can be a little bit more complicated, but it's manageable if you just do it systematically. Figuring out how to graph these things, that can be pretty challenging. And we're not going to do that much with graphing them, but you have to understand that composites of your basic functions make up most of the functions that govern things in the fields you're likely to go into.